So section 9.2 is all about the unit circle and trig functions. So we are going to put all of the emphasis today on the unit circle, because if we understand how to use the unit circle, then it makes the rest of trig much, much easier. So this is all about, section 9.2 technically is titled trig functions, but today we're only going to be talking about the unit circle. Okay. Before we get into the unit circle, I just want to make sure that we remember kind of what's going on with certain things. So like if we look at a geometry type question, if I gave you a triangle that looks like this, and I said that there were two values, like this was 45 degrees and this was 45 degrees, and I said that this angle was 1. If we know that each of these angles are congruent, that makes these sides congruent to each other as well, right? Because a 45-45 triangle is an isosceles triangle, which means that these two sides are going to be equal to each other. If I wanted to solve what x was, I would do x squared plus x squared equals 1 squared, right? So that would mean that this simplifies down to 2x squared equals 1, and then we would divide by 2, so we would get x squared equals 1/2, and then we would take the square root, and we would get x equals plus or minus the square root of negative of 1/2, right? So if we get something that looks like this, why do I not need the plus or minus here?
A distance can't really be negative.
X is a distance, right? So since x is a distance, I can't really have a negative number. So that means this is going to turn into x equals just the square root of 1/2. Now this brings us way, way back to being able to simplify things like radicals from a long time ago. The square root of 1/2 is the same thing as the square root of 1 over the square root of 2, which is the exact same thing as saying 1 over the square root of 2. This is not okay to have in the denominator. Since this is not okay to have in the denominator, I have to multiply by something called the conjugate. This also came out in the prereq chapter. So I'm going to multiply by the square root of 2 over the square root of 2. So 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 is positive 2. So that means my answer is going to end up being the square root of 2 over 2. Okay? So that's just a geometry review. That's just something to kind of think about. So when we're dealing with this, I want that to just be kind of in the back of your mind. The Pythagorean theorem exists. The ability to simplify radicals exists. None of that is going away, but it's going to be something that could be relatively important. Okay? So just kind of understand that that could be a very, very important idea. Okay? So now getting onto the unit circle, we can actually do the exact same thing with all of those things that you just saw on the unit circle. Okay? So if we look at the unit circle, let me draw a picture. If I look at the unit circle has a lot of tick marks all over the place, right? It's got a 30-degree mark. It's got a 45-degree mark. It's got a 60-degree mark. It actually shows you the 90-degree mark and everything like that. So let me get my coordinates drawn up. So if we look at this, it's got a whole bunch of marks, right? All of those marks that it has, we can kind of look at a specific one. So like if I specifically wanted to look at 30. So if I wanted to look at 30 degrees, this may not be perfect, but hopefully it's close. So if I wanted to look at 30 degrees on the unit circle, so everybody should be staring at 30 degrees on the unit circle. You should be able to see on the unit circle that it gives you two values out here. Those two values are the square root of 3 over 2 and 1/2. All right. So what I want you to kind of think about with this is we need to really think about these as coordinates, right? And the coordinates are pretty important because they're going to play into what we just looked at, what we just thought about. The y value here, like if we think of this as a point and we think of this thing as an x and y axis right here. So if we think of this as an x and y axis, this thing is a point. The x value is the square root of 3 over 2, and the y value is 1/2. That means if I were to draw lines that look like this, I would go, in order to get to that spot, I would go over the square root of 3 over 2. Oops. So I would go over the square root of 3 over 2, and I would go up 1/2. This thing makes a right triangle right here. So this thing makes a right triangle, and I know that it has side lengths of 1/2 the square root of 3 over 2. And I know that if in the unit circle, the radius is always 1. This is how all of these numbers are actually determined. This is how everything is figured out, okay? Now there's a couple different ways that we can do this. We all know that with right triangle trig, we can use SOHCAHTOA. Oh my good Lord. With right triangle trig, we all know that we can use SOHCAHTOA, right? And if we can use SOHCAHTOA, that means that we could use sine, cosine, and tangent. So if I know what this angle is, I could actually determine what every single one of these other values are just by using SOHCAHTOA, because I know in the unit circle the hypotenuse is 1. The only issue is your calculator does an incredible job being able to tell you what that value is, but it doesn't keep it exact. In calculus, your job is to keep almost everything as exact as you possibly can. Your calculator won't do that for you. Your unit circle will. So if I ask you to find something like the sine of 30 degrees, remember the sine of 30 degrees is the opposite over hypotenuse. So with SOHCAHTOA, sine is opposite over hypotenuse. So the sine of 30 degrees is equal to the opposite, which is 1/2, over the hypotenuse, which is 1. So the sine of 30 degrees is 1/2. All right. So this allows me to keep everything exact without having to use my calculator at all. Okay. So that's just something to kind of think about and to work your way through. This is just kind of a brief introduction as to what the unit circle looks like and how you can kind of use it. Okay. Is everybody good with this? Can I erase this quick? So I've got a good circle drawn and I don't want to have to do it again. So the next thing to think about is if I give, let's say I'm keeping this vague now. If I'm giving you just a generic angle, I don't know what that angle is, but if it's just generic, we'll call it theta. So if we have a generic angle that we call theta, the radius of the circle in the unit circle, the radius of the unit circle is always just 1. That doesn't mean it has to stay 1. That doesn't mean it has to stay whatever the unit circle is or whatever this radius is. You can change it to something else. So the unit circle just gives you what this thing looks like if the radius were 1 all the time. But obviously we could make it bigger. We could do whatever we need to do. But obviously what's happening is we're just going to, if we make the unit circle, or if we make the circle have a radius of 2, we're just doubling the size of it, right? We're making it 2 times as big. So if we want to think about this in a general form, I could say that the radius is just r. We had just talked about this point right here being the point x comma y, which means that we go up y units and we go over x units. So that means that I could create a right triangle with a side length of x, a side length of y, and a side length of r. So this would be x squared plus y squared equals r squared. Now in the unit circle, this is always going to be 1, so it's no big deal. So on the unit circle, we always have the value x squared plus y squared equals 1, and that's great. Every once in a while, it could pop up that the radius will be different, and that will be clearly notified to you if it's different. You can always assume you're dealing with the unit circle unless it specifically tells you otherwise. This is a very, very, very powerful statement in trig and calc. This thing right here is extremely powerful. We are going to use this all the time, all right? That's something that's going to have to keep popping up over and over and over again, and you have to know that it's going to be there over and over and over again. So you have to know that x squared plus y squared on the unit circle is equal to 1. Otherwise, it's whatever the radius is, okay? So today is mainly just a big thing about like generic form and general ideas and understanding what's kind of going on. So I'm just going through some examples and kind of identifying things with you, okay? So now, keeping by that same exact thought process, keeping on that same exact thought process, if I talk about sine and cosine, just like I did on the first page, if I talk about sine and cosine, sine of this angle, sine of theta, would be the opposite over the hypotenuse, right? So if we think about this, sine would be the opposite, sine of theta equals the opposite, which is y, over the hypotenuse, which is r. Cosine of theta would be the adjacent, which is x, over the hypotenuse, which is r. Now on the unit circle, I know that the radius is equal to 1. So that means that the sine of theta is equal to y over 1, which is just y. And I know that the cosine of theta is equal to x over 1, which is just x. So therefore, your unit circle is extremely important to you because the sine of whatever angle you're looking for is just whatever the y coordinate is. The cosine value is just whatever the x coordinate is. So the sine coordinate is really, really easy because you just look at the y coordinate. The cosine value of something is really, really easy because you just look at the x coordinate of it. So like if I look at my unit circle right now, if I want to know what the cosine of 150 degrees is, I know that the cosine of 150 degrees, that would be somewhere over here, it gives me my 2 points. My 2 points are the negative square root of 3 over 2, or it is 1/2. So looking at my unit circle, I know that. The cosine of that is the x value. So the cosine of that is this. So it is the negative square root of 3 over 2. Your unit circle makes it so you have to do absolutely zero work to figure out what the cosine and sine value of something are, as long as they're nice angles. If they're not nice angles, I likely won't ask you to solve them. So the angles on this are the angles that I'm going to ask you to solve most of the time. That doesn't mean that that doesn't necessarily mean that I'm going to only give you angles like 150 or 30 or 60 or 240. I'm not always going to give you those angles, but if I do give you those angles, I expect you to be exact. So if your angle shows up on the unit circle, I expect you to keep it exact, okay? But if it's an angle like 145, your calculator does a very good job approximating that, and I probably won't ask you to solve 145 by being exact because there's no way for us to really do that, okay? So anytime we deal with trig from here on out is probably going to be exact because it's going to give you specifically what those values are in an exact form. Now that also gives it to you in radians. So it also does the same thing in radians. If I ask you to solve, you know, like the cosine of, or the sine of negative pi over 4. So if I ask you to solve the cosine of negative pi over 4, one big thing that you have to notice right now is that your unit circle does not give negative values. So what you can kind of think of here is you can kind of think of the fact that your unit circle, even though it doesn't give you negative values, it gives you values that you know that you can deal with. So I know for sure that the cosine of negative pi over 4 is, like cosine of pi over 4 is right here, right? So if I'm doing the negative angle, it's in the exact same spot, it's just in the negative direction, right? It's just going this way. So cosine of negative pi over 4, you could also find the coterminal angle. You could do a lot of different things to figure out where this angle is. But the cosine of negative pi over 4 is in the exact same spot as 7 pi over 4. You could use the coterminal angle to figure that out. You could use whatever you need to figure out, or however you want to figure that out, you can do that. So this is in the same spot as 7 pi over 4. So if I'm asking you for the cosine of negative pi over 4, I'm just asking you what's the x value on this angle right here, and we can clearly see that it's the square root of 2 over 2. So the cosine value is the square root of 2 over 2. So this just allows me to find different angles and different methods, okay? So a couple important things to remember. The unit circle will give you exact values of sine and cosine given certain angles. And those certain angles are the ones that are located on your unit circle. Those are both in radians and they're both in degrees, okay? So they are both radians and in degrees. So you can find the cosine of any angle, whether it's radian or degree, as long as it appears on the unit circle in an exact form, okay? Your calculator gives good approximations. So like if I wanted to figure out what the cosine of 150 was, first thing, make sure your calculator is thinking in the right mode. So my calculator is in degrees, okay? If I want to find the cosine of 150, I would hit enter and it'll give me an answer, which is the negative 0.8660. That's a very good approximation. Remember, we figured out that it was the negative square root of 3 divided by 2, which should be the exact same thing. This is the exact form. Your calculator doesn't have a way to give you the exact form of what you're looking at, so just keep that in mind, okay? Your calculator can also calculate in radians. If you change your mode into radians, your calculator can also figure out what we just figured out in terms of pi. So the cosine of negative pi divided by 4, your calculator can figure out what that is. We figured it to be the square root of 2 over 2, which should be the exact same thing. So your calculator gives good approximations, it just doesn't keep it exact, okay? So understand that you have to keep calculations exact most of the time, okay? So we are going to be using the unit circle for most of our questions on here. So be comfortable using the unit circle. Be able to find sine and cosine values, okay? So you need to be able to find sine and cosine values for whatever we're dealing with. That's the only thing I want you to be able to do today. Get comfortable with it. Also, what I want you to try to do, so I'm going to put this on Google Classroom as well. I'm going to stop recording and stop. Actually, I'll keep recording this. But what I want you to be able to do is I want you to be able to find the sine and cosine values on the unit circle. It should be pretty easy, but it's something that you need to be able to do. The second thing I want you to try to do is I want you to try to find a relationship for tangent. Find a couple of angles or find a couple of whatever's on the unit circle and try to see if you can find a relationship between tangent, okay? Because if you think about what tangent was, tangent is the opposite over the adjacent, right? So if I already said that this was my y value, this was my x value, and this was r, you should be able to right now find a relationship for tangent of theta. I want you to see if you can do that and then put it to the test a couple times, okay? So that's what I want you to do for homework tonight. That's your job. Figure out cosine, the sine on a unit circle, be able to find the exact values of it, and then see if you can come up with a relationship for tangent, okay?